I'm going to use the same center of enlargement. However, what we're going to do is we're going to do a scale factor of half. Come on, Scoots. Right, so as we did before, let's do this bottom left. The nearest vertex is 2 along, 2 to the right, sorry, and 2 up. So guess where that vertex is transformed to? Well, because it's a scale factor of half, we've got to go half. So we're going to go along 1, up 1. So that corner goes to there. And again, you can probably at this stage draw in the rest of the shape. This side is 4, so I'm going to halve it, so it's going to be there. Then it's going to go across. Instead of going across 1, it goes across a half. You wouldn't get a question like that in an exam, but it's my question. It's broken. This side is 2, so it'll be 1, and then like that. So it is exactly half the size. The sides are all half the size of A. Okay, and this again will be a perhaps apostrophe. But the ray lines will still apply. Look. So it all works. Now I just want to show you another pith, because it can get harder, but just do the same thing as you're doing. Just do those steps. Set it out straightforwardly, not straightforward, I mean methodically, and hopefully you'll be all right. Because what we can do is we can do bloomin' negative scale factors, and I need to cover this because you'll see the result of a negative scale factor sometimes, and you think that is not an enlargement, because it does affect the orientation, meaning which way up it is. So anything positive, fraction or whole number, so half or 2 or 3, it's all the same, it's just enlarged. However, not the same for negative, but if you applied what we've just learned, you'll see that. So let's pick on this corner again, is nearest, so it means that I'm not going to makes less of a mess for me doing this one. So we're going right 2, why don't I write R2, that'd be nice, and up 2. So the right 2, guess where you're going to go if it's a scale factor of -2? Guess. This is right 2. First of all, think about the scale factor 2, and then think about the fact that it's negative. So this right 2 bit is going to send us left instead of right because it's negative, and double, so 4, because it's a scale factor of 2. So we'll go left 4, and we'll go down 4, D4. And then this one, I definitely wouldn't start drawing the shape until you've transformed a couple more vertices. So this corner has gone to there. And then this corner, I might not draw the guidelines for you because that just gets messy. You can find some critical ones. Look, if I find this one, I'll do that one in green, and then this one. Once you've done that and it's double the size over here, you can probably start filling in the rest. It starts to make a bit of sense then, but for the time being, so this vertex up here, 2 right, I can just write it anyway, in fact, can't I? 2 right, and then 2, 4, 6, 6 up. So of course, and this is the green one, so for my transformation, I'm going to do the opposite. So I'm going to go 4 left, sorry, opposite and double it. And I'm going to go to 12 down. So 1, 2, 3, 4 left. I have to move the board up a bit. And then 12 down. So this is 4, and then another 4, and then another 4. I'll definitely count that twice. Nice. So look. So that is the longest side of our shape. I still wouldn't fill it in just yet. Let's do this purple one just to confirm. Once you've got 1 or 2 sides, you'll start to see. But at the moment, it's not going to be as expected. So the purple one is right 4. So going from the center of enlargement to the vertex, we're going right 4, and then we're going up 2. So you guessed it. Instead of right, it's left. Instead of 4, we double it, it's 8. Instead of up, it's doon. And instead of 2, it's foul. I don't know what that accent was. So I only need to see the centre of enlargement now. Purple, left 8, down 4. So that's 4. That's 8. Down 4. So that side has moved to here. So let's have a look at this. So look how this is the outside. I'm kind of thinking, if you think of this as the inside, this is the outside of our L. Outside of our L. Bear in mind it's a scale factor of 2. So this side is 8 because the original object was 4. And then you can probably spot that, well, that's going to have to go there. On the original object, this side was just 1, so I'm doubling it. And then I'm going to go down here to, I think, 4. No. Let's have a look. So this is why in an exam you're going to transform each vertex to avoid these kinds of mistakes. So 1 1, good. So I'm going to keep on trucking down here to 2 and then like that. So this side was originally 1, so it's now 2. This is 2 and it was originally 1. Blah 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 blah. You can check that this is double the size. A apostrophe. But look, let's just take a moment to look at the orientation of the shape. So if you look at it, it's kind of like a, well, it is a rotation, but it's then been enlarged. So if you're asked, if you're given the object in the image and asked what transformation, it will often ask which single transformation, because otherwise, well, we could rotate it and then enlarge it. So it'll say single, and that'll be your hint, because you think, oh, well, it's a rotation. It can't be, because it's different size. Oh, it's reflection. It can't be, because if I turn my head on the side, if I fold one over onto, well, they're different sides anyway, I can ignore the rest, but it's also not a reflection even if it was the same size. A translation is just a movement, so it can't be that. So it has to be an enlargement. And then you can start thinking, goodness knows, what enlargement is it? And then you can pull that apart. So there you go, we've covered, so enlargements with the center of enlargement, that's what you need to be doing. Because we can all just double the size of a shape. So you've got the center of enlargement. We did a scale factor of 2 to be, or 3. A positive one, we did a scale factor of 1/2, and then we did a negative scale factor. Okay, and all you're doing really, oh, and I can, oh, by the way, the ray lines still work. Always the ray lines. So that's how I was taught to do it, and that's my preferred method, is just using the ray lines. You just draw the ray lines in, and then you can work out, boom, that's where the shape goes. But in my experience, students don't prefer that. So that's why I teach both ways. So again, it's not going to quite line up exactly because my ruler doesn't give me such options, but whoops, I'm not going too far away. There you go, so go through there, and then I can, I line that with there, it'll probably stay still. Anyway, I can't resist at least doing one more, otherwise you'll never believe me. See, that's not really lining up. Look, the room for error is not small enough. But it still does work. So you can still always use these ray lines. You're just going to draw it straight through the center of enlargement. Just keep on going. This corner will line up with this corner behind here. Move that. This corner behind here with that corner. This corner with that corner, etc., etc. Okay, so that's an enlargement, a negative enlargement. Fraction would be the same, but you know, if it's 2.5, if here I've gone 2 right, I would have to go 5 left. 2.5 times 2. It's unlikely you've got negative fractional enlargement, but it does happen. Okay, and that is enlargements. So basically you're just counting, if you're choosing that option, you're just counting from the center of enlargement. Get to work out where each corner is of your object, and then multiply it by the scale factor. Okay. Hopefully that is clear. Good luck.